morning. I just wanted to have a few thank yous before I go into my presentation. I wanted to thank the ARC Advisory Group for putting on such a productive conference. I feel like I've come away knowing a lot of valuable information that I could take back to the plant and implement and become better at the end of the day. And also Mr. Resnick for moderating this forum, and to Stratus for providing me with this excellent opportunity to speak to you guys and to bring you our story today. And also the team at Rubberlite. I love working there and I love working with all of them. So I am Jessica Spurlock. I am the process automation engineer for Rubberlite, and I started working out in a variety of industries about 10 years before I joined Rubberlite in 2011. And like I said, my title is Process Automation Engineer, which basically means that everything from where the power comes into the building at the switchgear, all the way to the operator's HMI or machine graphic interface, everything in between that is my responsibility. So Rubberlite Incorporated is a privately held company that's based in Huntington, West Virginia, and it's been operating there for over 30 years. Huntington is located on the banks of the Ohio River, which is strategically located between the Midwest, the Southeast, and the Mid-Atlantic regions in the tri-state area of Ohio, Kentucky, and West Virginia. And Huntington is also the home to Marshall University, which some of you might know of from the plane crash back in the 70s. And they made a movie about it in 2006 with Matthew McConaughey. And they actually filmed it in Huntington, which was kind of cool. But Rubberlite itself, which you may not have heard, a lot of people have asked if it's the same thing as Rubbermaid, which it is not. But I'll tell you a little bit more about what Rubberlite does. But we employ over 170 people with an average tenure of 11 and a half years. Our campus, as you can see there in the picture, extends over an entire city block with 300,000 square feet under roof. So Rubberlite's business model is based on two key operations centers. First, we are the recognized leader in converted cellular rubber and plastic products, and we're actually the leading converter, or the largest converter of cellular rubber products, of bun stock specifically, in the United States, out of a little town called Huntington, West Virginia. And we've been doing this since we opened our doors in 1986. And then in 1997, we figured we can do this part ourselves, so we did. And in 1997, we became the leading manufacturer of custom-engineered, medium-density, free-rise, polyurethane foams. This operations center accounts for approximately 50% of Rubberlite's revenue stream. And in the early 2000s, Rubberlite began offering flexible composite systems and textile coatings as a value add to the product from either operations center. But we service over 1,600 customers worldwide, and our products have a broad range of applications, from medical, footwear, industrial, automotive, aviation, apparel, and flexographic printing. And what sets us apart is the integrated R&D, the production, and the sales force all being under the same roof. The manufacturing department was chosen for the beta site for this implementation, becoming the blueprint for the rest of the organization with regards to automated process controls, data integration, and just overall a higher sophistication of operating discipline. And it had the processes and the technology in place as far as PLCs and Ethernet IP devices, and the potential benefits from a successful implementation would provide the most value to the company. So the Rubberlite aim is what our CEO, Alan Mayo, founded Rubberlite based on this overarching goal: to aggressively grow our company by meeting or exceeding customer requirements, developing innovative processes and products, while continually improving the levels of safety, quality, service, training, and personal development and profit. And the underlying portion was added in 2011 to bring Rubberlite up to world-class operating standards. This new mandate was the basis for implementing the Supervisory Control System project. So what was it like before? If the company did bad or good, or the production line, they didn't really have a good reason why. They didn't really have the data to back it up. We had binders and binders of run sheets in our manufacturing department, and we had targets on these run sheets, but we had no actuals to compare it to. It was just a disjointed snapshot that the operators would write down information as they were running. And data collection happened on the plant floor PC, and it only had a 15 gigabyte hard drive, which limited the amount of data collected. So we only logged the data during production. If something happened when we were not running product, then we had no record of what actually happened. And the CSV exports from the primitive logger were cumbersome. It usually took me about an hour to generate just one report from a 2-hour run. And as we mentioned before, the average tenure of a Rubberlite employee is 11.5 years. And with that comes a lot of head knowledge, or tribal knowledge as it's more commonly known, with limited standardization across the board. So the products, therefore, had variable repeatability because everybody did everything differently. The tasks weren't performed in the same manner. So combining that with the 2 points that I previously mentioned, it was not a very sophisticated way of operating. The manufacturing line was run from a single HMI running on a single Windows XP PC running on the plant floor. Now, if this single computer went down, the manufacturing line was in big trouble. Granted, I would periodically take ghost images of the hard drive and store them off-site in the cloud and off-site at a hard drive off-site. This wasn't an ideal situation, of course. And due to the surprise events and the undefined process capabilities, the execution style of Rubberlite was largely reactive in nature. But in spite of all this, Rubberlite has been very successful in the development of specialty products in niche markets. This kind of success can lead to a natural evolution of culture that is more resistant to change due to the commercial effectiveness of the status quo. There's often a risk to change, and the mentality, if it ain't broke, don't fix it, can be prevalent in existing work processes and new technology implementations. And it's understandable, of course, but this can impede continuous improvement initiatives. So the implementation of the Supervisory Control System project was a prominent step in Rubberlite's commitment to growth and innovation. So Craig asked in his presentation what was the most important consideration in choosing a solution to reduce downtime and increase plant KPIs. For Rubberlite, I would give 2 answers since we are a smaller organization with limited resources. First, the solution has to be simple to operate and maintain. And second, it must have significant value throughout the system's lifetime when considering the total cost of ownership and return on investment. So when considering these 2 answers, the path forward was clear for us. With the help of our distributor, Rubberlite had decided on a fault-tolerant server to run our chosen control systems technology architecture. It is better. So combining a fault-tolerant hardware, software, 24/7, 365 monitoring service in a complete turnkey solution. It prevents application downtime instead of recovering from it. And it works seamlessly with existing applications and system management tools. It's safer because it provides totally redundant servers to prevent single points of failover. And it has something called an automated uptime layer, which prevents many errors from escalating into outages. And it's faster because the online diagnosis and component replacement makes it easy to do changes on the fly. Replicated and fault-tolerant hardware components process the same instructions at the same time. So it's basically 2 computers working in lockstep together. And so in the event of a malfunction, the redundant component just acts as an active spare that continues with normal operation without system downtime or data loss. And it winds up being cheaper when you consider the total cost of ownership and ROI, because it eliminates the need to purchase multiple OS and application licenses, external storage arrays, and network switches. It also reduces the system administrative costs without the need for modification or complex scripting. So our architecture looks like this. We've got 8 VMs. We chose VMware as the backbone for the virtualization, like Trevor explained in his thing, except they used Hyper-V. But basically, it's the same sort of scenario, except instead of running on two different independent servers, it's just running on the one fault-tolerant server. And as I'll go into later, the network thinks of it as one machine. So we have our two I/O servers that are redundant to themselves, and our visualization servers that are also redundant to themselves. The MES server, which is not in use yet, or the web server, or the other server. And then we have our development node that's a little bit more beefy because it has to handle all of the historical data and the processing of our application development. So other benefits are this object-oriented technology of this control system software. And basically, it allows changes to be propagated across the entire organization, and you only have to make the change one time, so you don't have to change it in individually applications that house that component. So that way, operators can quickly absorb changes to standard applications, reduce operation errors, and shorten learning curves, which would cause downtime. The historian doesn't store data in SQL directly, but it uses this highly optimized history block technology. That means you don't have to purge the database size as it grows, ever. These history blocks can be backed up using something like Windows Explorer, which would improve IT maintenance labor costs. And the software has several types of queries that can be run to compare different runs, and you can, it's easier that way. And it's faster than searching through 20 years of binders for run sheets, or even rows on an Excel spreadsheet. And it allows the operators to visualize process data in real time as they're running line on the product. So that way, if something happens as you're running the product, you would know about it in the first 50 feet, and you only scrap that 50 feet instead of running 400 feet of bad product. So that real-time visualization is a huge win in that case, and I'll go into that a little later. Thin client hardware on the plant floor is more robust and reliable than traditional PCs because there's no moving parts. They're much faster to configure and replace than traditional PCs on the plant floor, and the software that manages those thin clients includes a technology called instant failover, which runs sessions on a secondary server to prevent downtime from server failure. And also, you don't have to run as many machines on the plant floor since you can layer different applications on the same monitor and easily switch between them, or you can display them on a matrix of monitors. And the software supports high availability requirements with support for the latest virtualized technologies from Microsoft and VMware, which consolidates systems, optimizes and unifies hardware, and reduces costs. And the centralized deployment capability eliminates the need for someone to go to each computer and update applications, which saves on labor costs. The common platform eliminates the costs and risks that is attached to the integration with operations management, process supervision, and process control, and really enables true long-term project sustainability. So, the Supervisory Control System project, as you can see by the graph, was implemented in March 2016. Now, because we are a privately held firm, we can't really disclose size of company, so I apologize that the graph is a little bit hard to translate, but we have some hidden accesses. But as you can see, Rubberlite had observed a 65% reduction in scrap while increasing production volumes 15% from the implementation to today. And even though this is not it's not the only thing that happened to, increase our productivity and reduce downtime and increase our KPIs, I believe, and I would argue, that the implementation of the fully integrated DCS and data historian with the fault-tolerant server as the backbone has facilitated this growth because we are able to better visualize the data in real time, allowing us to, like I said in my example earlier, eliminate a bunch of scrap problems before they happen and become more proactive instead of reactive. So this is a phased process. As I said, the manufacturing line is what we have concentrated all of our efforts on, but we have the different departments, being the technical composites department. We're in the process of implementing that software to that department, and the other departments are next on the list, and that's because of the technology constraints. And here's where we're going with regards to the Industrial Internet of Things, or IIoT. Our thin client software allows for users to access sessions over mobile devices such as a smartphone or a tablet. And one of the cool things that we could also do is we can install QR codes on a lot of our devices and equipment pieces and be able to scan those QR codes with our phones and get the data about that piece of equipment. Like, for instance, a motor, we can get wiring schematics, data sheets, pump curves, PLC programming, if it's a drive, drive parameters. I mean, the list kind of goes on and on of what our capabilities could be, but that's going to revolutionize our maintenance and be a quicker response to some of these things. We're moving our historical data to a private cloud environment, and using the mobile devices, they can access this historical data to make informed business decisions. Another thing that we're looking forward to doing here in the near future is to provide management with a real-time, at-a-glance visualization of how our plant is doing, with relevant dashboards and analytics related to downtime, KPIs, overall equipment effectiveness, or OEE, predictive maintenance, and more. So that way, the machine operators can look and see how they're doing from actual to target, and also management can just look around and see if everything's green, yay, if everything's red, it's not so good. And even our customers like to see that kind of real-time feedback. And it's, like I said, it's so we know how we are doing in real time, an easy way that we can get either on those kiosks or on the dashboards in the plant or on our mobile phones. Though technology upgrades have been the main focus of this presentation, it is so important to note that without looking at the people, the processes, the benefits of technology fail to be realized in a sustainable manner. So the ultimate goal of the supervisory control system is to align our people, our processes, and our technology in order to ensure sustainable results through disciplined execution. Thank you very much.